Okay, next topic is sketch-based modeling. And the work we introduce here is called TEDdy. And the problem we want to address here is that 3D modeling is difficult, especially modeling of low-tuned 3D organic shape is difficult. So typical user interface is like this. So typically you have 3 views, and you have top view, front view, left view, and you put many vertices, and then you put many edges, and you create many faces, and you have to combine many commands in nested menus, and also many parameters. And this can be very useful and ideal for professional production for movies or TV shows or cars and products. However, if you want to use this kind of system for communication, this is way too difficult to do. However, on the other hand, if you have a pen and paper, you can quickly draw something meaningful. And more importantly, if you look at this kind of image, you can infer some geometric information. For example, probably this face is kind of low-tuned shape, and then also hands should not be larger head or something like that. You can get general idea. So our idea is to implement this kind of visual intelligence into a computer to make a useful 3D modeling tool. So that's the idea. And let me show you a demo. So again, you get the blank canvas, and you pick up a pen, and you directly draw a line on this canvas. And then here you draw something here. And then as soon as you finish drawing, system automatically inflates it. And then you get this 3D shape. So now this is already 3D. So you can see it from front or top. Or you can also rotate through it. So you get a full 3D shape here. And you can also cut his object. And you can also paint it and cut it. And you can also add and bump. So in this way, you can generate reasonable 3D object just by drawing outline of the intended shape. And internally, this is standard 3D object representation. So if you use traditional tools, you have to combine many commands, and also you have to manipulate many individual elements. It can be very tedious. And let me describe some little bit individual operations. First operation is creations. On the blank canvas, you draw closed region, and then system inflates it. So if you draw circle, and you get a sphere, and if you get long bar, you get bar, and you can generate this kind of snake shape, and so on. And the algorithm is, basic idea is like this. So if you have a large region, system inflates a lot. And if you get a narrower region, system inflates a little. So in this way, you always get a cross section. Looks almost circular cross section. So that's the idea. Let me turn off the sound. And so this is very powerful. So for example, you can get this kind of shape, or you can also get this kind of shape. So again, input is just a simple 2D stroke, but system generates some reasonable shape from simple 2-dimensional sketch. And after having a 3D geometry, you can interact with it. First, you can paint on it. Your stroke is projected onto the 3D surface. And you can also erase them by scribbling. And then if your input is inside of the object, it will be projected and painted. However, if your stroke comes outside and inside and outside, it will cut the object by projecting the line. And then this is useful for intersection, like getting this shape, or you can make a mouse like this way, and you can paint. Okay, so that's a cut operation. And next operation is extrusion or bump operation. So if you want to add a bump, you draw a closed region and rotate, and then draw a second stroke. So this is two-stroke operations. First stroke defines a domain, and the second operation stroke defines a silhouette. So this is basically sweep or extrusion operation. So this is the input. It's first stroke, second stroke, and you will get this. And this is very flexible. For example, if you draw this kind of shape, you get a snowman kind of shape, and you can also make a mushroom kind of shape this way. And if you draw outside, it will generate a bump. But you can also draw inside, and you will get a cavity, and you can get the structure like this way. And another example is thin plate-like shape. So if you draw this domain, and if you draw this shape, you get a wing shape. And again, you draw this shape, and then this shape, and then you get the wing. So in this way, you can generate a kind of a bird. And after having some object, you may want to deform or edit it. In order to do so, we also provide sketch-based operations. So it's called this bend button. So this takes 2 strokes. First one is a reference stroke, and second one is target stroke. So let's draw a reference stroke, and then draw target stroke. So what system tries to do is deform the shape so that red deforms into blue, and you will get this result. So in this way, you can get reasonable 3D shape by sketching. And this deformation tool is very useful. So again, press bending, and then red is input, reference, and then blue is target. And then you will get this kind of shape. And you can also reference and then output, and then you get this shape. So by combining these operations, you can get a shape something like this. And let me show you a couple of 3D models painted results. So all these models are created using this technique and painted using traditional painting interfaces. And you can see one can generate reasonable 3D object using this technique. So let me describe the algorithm a little bit. So here's an overview of the algorithm of inflation. So this is 2-dimensional user input. And then first thing computer do is first identify an axis or skeleton of this closed domain, so center line. And after computing this center line or axis, we lift it, raise them in this way. And the important point here is that the amount of lifting depends on proportional to the distance to the silhouette. For example, here the distance is very large, so it gets higher. However, here the distance is very short, so it's not to get higher. So in this way, you get reasonable shape. And after that, remaining task is just simple. We just put overall shape around the axis and the silhouette to get final result. So this is the overview. And let me describe step by step. So input is 2-dimensional polygon or polyline. And then after that, we apply constraint Droney triangulation. This is very simple computational geometry operations. Just triangulate them. And then after that, we compute an axis by connecting midpoints. So this is again very simple operation, but very powerful tool for analyzing the shape. And this technique is introduced by Prasad in 1997. And after connecting the midpoint, you get 3 kinds of triangles. One is this kind of junction triangles with no external edges. And another is 3 triangles with 1 external edges. And also terminal triangles with 2 external edges. And having this, the next task is to trimming. So before trimming and after trimming. So in order to inflate or lift central axis, we have to remove trivial edges like this one. And now, let me describe how to do this trimming operations. So trimming starts from the end of the axis and then remove them one by one. So it works like this. So if you get this situation, starting from each terminal, we pick up a terminal edge and then draw a circle, hemicircle. And if all edges, all tips are inside of the hemicircle, you go inwards, like this. And again, draw a semicircle, half circle, and check everything is inside. If everything is inside, go further. And now, if vertices some vertices outside the circle, then we stop the trimming operation, and then you will get these terminal triangles. So that's a trimming operation. And after applying this operation, you get this ideal shape. And this is almost done. After you get this central shape, you just lift up this central axis proportional to the distance here. So if you look at here, you have silhouette line and center line, and you lift it up in this way, and this length is average of these surrounding edges. And after that, you just put a quarter of a circle in this way and in this way, and then just stitch them together. And the application of this system is for enhancing communications. This technique is not good for production of movies or TV shows and so on, or car designs, but this technique is very useful for face-to-face communication with somebody in front of whiteboard. Let me show you a couple of examples. So one possible application is education. For example, in a biology class, the teacher may say, this is a bacteria, and then internal structure is like this. And the students can understand kind of three-dimensional concept. And another possible application is medical applications. For example, doctor may want to say, this is your stomach, and then you have a serious problem here. And then doctor can say, let's fix it, and so on. And or dentist may say, this is your tooth, and again you have serious problem here and there, and then you need to remove them, and so on. And one particular interesting application we want to show is teaching of geography. Geography is a concept of mountains and valleys and rivers, lot of three-dimensional ideas, which can be very difficult to understand sometimes using two-dimensional whiteboard. But here, if you have a 3D sketching, it can be very useful. The example we want to show is a teaching of contour lines. I think you may know the contour lines. On the two-dimensional map, you see lots of lines indicating heights, but it can be difficult to understand what they mean. But here, the teacher can say, now you have some mountain here. So mountain side view, front view, and top view. So you have one mountain here. And now, let me draw lines indicating equal height. Say, this is 10 meters high, 20 meters, 30 meters, 40 meters. So these lines indicate equal height. And then this is side view, the front view. And if you look them from the top, now you see this is the contour lines. And then you can learn many things like sparse contour lines indicates gentle slope, and dense contour lines indicates sharp slope, and so on. So yeah, so this is a main application we are thinking of this kind of sketch-based modeling. Okay, so to learn more, first I recommend you to take a look at the original paper. It describes the details of the algorithm, not only creation but also extrusion and cutting. And the technique we used is a caudal axis, and it was called morphological analysis of shapes. And this is very useful tool for analyze shapes and so on. And we introduced polygonal mesh-based inflation algorithm, but another possible approach is using implicit surfaces. It automatically generates smooth shapes like this one, so it generates smooth connection, and the user can also change the configuration later. And this one is called ShapeShop and published in 2005. And I think application is also available, so I recommend you to try them too. Thank you.